Hello, welcome back. This is topic zero point 0.2, I believe, of my AP Biology series. Today we're going to be going over some foundational concepts that you need to know for AP Biology. So let's say you're going into AP Biology, never taking a science course before in your entire life. That's a bit of a stretch, but I know a lot of people, including myself, went into AP Biology without chemistry under their belt. So I wanted to go over some basic chemistry concepts that will make AP Biology so much easier. You really need chemistry, especially for Unit 1, a little bit in Unit 2, and some in Unit 3, I think. So it's really important to get these basics down before you head into AP Biology. So even if you're in the first week of the course or, let's say you're on Unit 4, it doesn't matter. It's good that you're here, and let's go over some basic chemistry to start. So in chemistry, the most basic unit of matter is called an atom. An atom is made up of 3 subatomic particles. We have protons, neutrons, and electrons. So we're going to start with protons, and for each of these subatomic particles, we're going to break them down by mass, charge, and location within the atom. So that is mass, charge, location in the atom. So let's start with protons. Protons have a mass of 1, and the unit on that is technically AMU, or atomic mass unit. Don't really worry about that, just know they have a mass of 1. Their charge is a positive 1. They have a +1 charge. And they're located within the nucleus of the atom. And I'll show you what that means in just a second. But basically, it's the center of the atom. Now, neutrons, they also have a mass of 1. But they do not have a charge. They are neutral. Neutron, neutral, proton, positive. So we'll put a 0 for the charge. They are also located in the nucleus, or in the center of an atom. Okay. So for electrons, they're super, super tiny. I think the mass of it is like 1/2000th of a atomic mass unit. So when we're looking at the mass of an atom, it's pretty negligible, so we just say the mass is 0. We don't count it when we're counting the mass. When we're talking about AP Biology, for the scope of this course, just say it's negligible mass, 0. For the charge of an electron, we have a -1 charge. It has a negative charge. And electrons are not located in the nucleus. They are located in what is called orbitals. Orbitals are located on the outside of the nucleus. So they're we draw them like rings, but really think of them as clouds that go around the nucleus. Okay, so now that we broke down all the subatomic particles, let's look at how they all fit together in an actual atom. So I'm going to draw a picture really quick. Okay, so this is an example of an atom. Now the scale's not perfect. You can see that some of the electrons are bigger than the protons and neutrons, but just for now, this is what an atom's going to look like, okay? So we are going to determine what element this is, what the mass of the atom is, and what the charge of the atom is. So let's start by what element the atom is. So elements are determined by the number of protons. All atoms of hydrogen have 1 proton. All atoms of helium have 2 protons. All atoms of barium have 56 protons. So if an atom has 3 protons, for example, it's always lithium. Or if an atom has 2 protons, for example, it's always helium. So the number of protons always correlates to a certain element. If I add or take away protons, it changes what the element is. So let's say I start with 2 protons, that is helium, so helium has 2 protons, and I take away 1, it's no longer helium, it's now hydrogen, because it's always determined by the number of protons. So we know that this particular atom has 1, 2, 3, 4, 5, 6, 7. So if we look on the periodic table, we can see that the element with 7 protons is nitrogen. So any atom that has 7 protons is a nitrogen atom. So this is an atom of nitrogen. And I'm going to use the atomic symbol here, N, to show that this is nitrogen. So this is a nitrogen atom. Okay, and we know that because of the number of protons. So now let's figure out the mass. And remember how I said neutrons and protons are the things that determine the mass of an atom. So we're going to count the number of neutrons and protons. So let's start with the protons. We're going to do a quick shortcut here. I know we already counted the protons. We know nitrogen has 7 protons. So we know we have 7 protons, right? In order to find the total mass of the atom, we have to add 7 to the number of neutrons. So the number of neutrons is 1, 2, 3, 4, 5, 6. So we have 7 plus 6, which is equal to 13. So we have 13 mass. That's our mass. The mass of this nitrogen atom right here is 13 atomic mass units. So we're just going to put a 13 here, right? That's how we find the mass. Okay. Let's see what else we got. The charge. So the next thing is we're going to look at the charge. What two subatomic particles will determine the charge of an atom? It is protons and electrons, right? So we're going to count the number of protons, and we're going to subtract the number of electrons from that to find out the total charge. So if protons are positive, right, and electrons are negative. So if I have more protons than electrons, let's say I have 4 protons minus 2 electrons, I have a charge of positive 2, right? My charge is positive 2 because I have more protons, I have more stuff that's positive. However, if I had, for example, more electrons than protons, let's say I had 2 protons and 4 electrons, my charge would be negative 2 because I have more of the negative stuff than I do the positive stuff. If I have the same amount, then it's 0 and there's no charge. It's a neutral atom, right? So we are going to count. So we have 1, 2, 3, 4, 5, 6, 7 protons minus 1, 2, 3, 4, 5, 6, nope, 7 electrons too. And that gives us a charge of 0. So this atom has a 0. There's no charge on it, which is pretty awesome. So based on this information, we know that we have a nitrogen atom with a mass of 13 and a charge of 0. Okay, so now we're going to talk about electrons and how they are super, super important for AP biology. You know, I just spat a whole bunch of chemistry stuff at you that you're like, how does this have to do anything with evolution? Now I'm going to explain to you why it's super important that we understand how electrons work specifically. So in an atom, you know, I had drawn those rings and then I put electrons in the rings and I put them in a specific way. You know, this shell right here, this outermost shell is the valence shell of this atom. If, for example, I were to take out this whole orbital and I pointed to that is now the valence shell of that. It's just the farthest out ring, right? If it only has one ring around it, a full valence shell would be 2 electrons. If it has an additional ring around it, like this, a full valence shell would have how many electrons? 8, right? Because every ring after the second one contains 8 electrons, in theory, in AP biology. That's all you have to know. And atoms are happy when they have a full valence shell. Now, what happens if they don't have a full valence shell? Let's say we have an atom that is missing 1 electron. Let's say it's missing this one right here. It only has 7. What is it going to do to get that extra electron? It can do a couple things. It can steal an electron from another atom. That's kind of mean. Or it can share electrons. And in AP biology, we really focus on the sharing of electrons. The sharing of electrons creates what is known as a covalent bond. A covalent bond is when 2 atoms share electrons to obtain a full valence shell. And I'm going to explain what that means because that was a lot of mumbo jumbo. We are going to start with the simplest atom, and that is an atom of hydrogen. It is the simplest because it contains 1 proton, 0 neutrons, and 1 electron in its most, common form. Now, is the valence shell of this hydrogen atom full? No, it's not. It only has 1 electron, and it needs 2 electrons to be full, because remember, it's the first ring. We're walking down the street, and we see another hydrogen atom. Is this guy happy? Does he have a full valence shell? No, he doesn't. He only has 1. He needs 2 to have a full valence shell. So what often happens in biology is that these 2 guys, they'll come together and they'll say, hey, in order for us to both be happy, in order for us both to have a full valence shell, why don't we share our electrons? They share their electrons. And it's a little bit more complex than that, but now they both have full valence shells. Even though now they both have full valence shells because they're sharing those electrons. They both have 2 in their valence shell, even though they're sharing 2 between them, right? So these are both happy, and this creates a covalent bond between these two hydrogen atoms. So when atoms want to obtain a full valence shell, they oftentimes share electrons, creating a covalent bond between them. But covalent bonds aren't always fair. Sometimes one of the elements or one of the atoms within the whole molecule likes to hog the electrons, and we're going to look at that within water. So water is I'm not using a pen. Water is H2O, right? Who remembers? H2O. Water is H2O. What that means is that there's two hydrogen atoms, bonded to one oxygen atom, right? Like that. So we have H2O. Now, we already know what a hydrogen atom looks like, so I'm going to draw that really quickly. That's just, remember the proton with the one electron. And we have times two of those, right? For oxygen, though, I want you to, by your own, try and draw it by yourself and see if you can get the configuration. So now, hopefully your drawing looks something like this. I know my webcam's blocking it a little bit, but we have 8 electrons, we have 8 neutrons, and 8 protons. The atomic mass of this oxygen atom right here is 16 AMU. The charge is 0 because we have an equal number of protons and electrons. And we know it's oxygen because we have 8 protons. So now, in one water molecule, we have 2 H's and 1 O. I want you to notice that in this 1 O, we are missing 2 electrons. And so in order for oxygen to be happy, in order for it to gain its full valence shell, it needs 2 electrons. We have 2 hydrogens, each with 1 electron that it's willing to share with oxygen. So I didn't draw in all the protons and neutrons because I'm pretty lazy, but what happens is each of the hydrogens are going to gain a full valence shell because they'll share their electrons with the oxygen, and the oxygen will share 1 electron with them. So now we have 2 in this little connection or this little bond. Oxygen starts with 6 in its valence shell, and then it gains 2 from 2 different hydrogens. However, oxygen is a very greedy atom. It does not like to share the electrons. It likes to hog them, actually. This is called electronegativity. Oxygen is more electronegative than hydrogen, meaning it likes to hog the electrons more. What ends up happening is in a molecule of water, the electrons tend to hang out over here more often than they do near the hydrogen. They're still being shared between the hydrogen and oxygen, but they just like to hang out near the oxygen more because the oxygen's kind of hogging them. It's more electronegative, it's hogging the electrons more, right? So because all of the electrons are hanging up by the oxygen, it actually makes this end of the molecule more negative, okay? Electrons are negative, so wherever they are creates kind of more of a negative force, right? So over by the oxygen, because the electrons are hanging out by the oxygen more, it's a little bit more negative, and it tends to be more negative. Now, if this end's more negative, that makes the hydrogen ends more positive. But the sharing's not always unequal. Sometimes the sharing is equal. There sometimes is never a hog. So let's look at methane, for example. That is CH4. The electrons are actually shared pretty equally. And so CH4, methane, is known as nonpolar. The bonds between C and H are nonpolar covalent bonds. It gives it different properties from polar molecules, which I'll talk about later in my actual AP Bio series. So that's all for topic 0.2. If you have any questions, you can leave them in the comments. Thanks for watching, and see you next time.